Have a wonderful good morning, wonderful good lunchtime, wonderful good afternoon. Good to have you all around for our webcast about virtual reality here with A2K. So we had just a bit of a 2 minutes delay. We got some technical issues, unfortunately, but can happen to everybody. Server didn't respond regards to the webcast. So we got this sorted now. This is good. So it came back. So everything is nice, and we should be able now to talk and chat a little bit about interactive technologies around virtual reality and actually others as well. So that's a little bit the agenda. What I thought to run through today. Just a quick catch up about virtual reality. I see there are a few around who haven't been on this webcast before, so just a quick sum up. But the idea is actually to talk then about interactive presentations actually and interactive techniques, going a little bit further, offer a series of our three applications, or 4 or 5 applications. Let's see how many we can actually quickly run through. Good, you probably know A2K Technologies. We are in the Asia Pacific and looking after the efficiency of the companies and the Autodesk business, as well as all the other application you might use at work. So we try to get you equipped and try to get you and productive and using it. So to myself, looking after the visualization and simulation here, so hence I have the big honor and the big joy to so the big honor and the big joy to talk about virtual reality today. And good. So virtual reality is actually a communication tool, is what we know and what we have seen, especially in our first webcast, that it actually goes back a long time to the 15th century and so on. And over the time, it actually became more electronic. So that basically, could say basically electronically. And but on the one hand side, we had actually visions about virtual reality, as well as we actually also developed different gears over the time. Let's see, for instance, in the 90s. And well, we probably have some mainstream gears now around, be it, for instance, with the HoloLens, be it from Microsoft. We have, for instance, also from Oculus Rift or HTC, and from IBM, or basically from Lenovo and Dell and HP, also headsets, which actually allow us to view actually and experience actually our scene actually in stereo. So basically what the computer does, it just renders a left eye and a right eye on our headset, while we have actually sensors, and as soon as we actually move our headset to the left, to the right, that the computer basically updates actually the picture for that. So this is basically what's actually happening. We have in the last webcast, we talked a bit about the different senses actually, and so we actually just focus on the eyes and actually on the hearing. So other like touch, feel, and others, there are some techniques out to have maybe some gloves which stimulate basically the nerves electronically, but it's not. It's not a mainstream virtual reality experience we actually see. Good. We also have seen that a lot of applications are out there. A lot of companies are actually developing around and are in the virtual reality industry. We see here an example on the right-hand side, solution from HP, the HP headset, and as well as that we see here on the bottom, for instance, also a computer you can actually, basically a laptop you can carry as a backpack. And we have our controller. With the controller here, obviously, we have here a couple of markers. It's basically here some lights being recognized by the camera, and then the computer reverse engineers this back, and we can actually we can set up an interactive environment for ourselves to design, as well as actually also for our clients actually to experience the space. So it's all about experiencing the space and experiencing actually our design for that. So there are a couple of solutions we have presented over the last and along the last webcasts. One of the easiest is actually straight out of Revit, that we use, for instance, our A360 stereo rendering being rendered in the cloud. And basically the stereo picture what you have just seen before was actually rendered there. So it's basically what actually Autodesk renders. And so we have here the option just to take actually our mobile phone, put this mobile phone in the cardboard box, costs a couple of dollars. We can actually even print our own company logo actually on it and give it out and send this link to our clients, and they can actually immediately experience it. However, it doesn't allow to walk through, so that does not work. However, but it updates as soon as you, for instance, want to tilt your head, or as soon as you roll your head, that actually does update. Moving is to move around is not possible. So for this, we actually have other applications, be it, for instance, here from Autodesk Live, or some are probably familiar already with Enscape, that we actually can just plug this in. We have also seen a little bit the advantages and disadvantages of these applications. I mentioned a few things. Good. Additionally, today, in the whole interactive webcast here today, that we want to actually have a look at interactive, to use Max Interactive or former project Stingray. You might have heard about it, and actually also Unity 3D, and actually compare this a little bit. I thought with interactive, we make our lights a little bit interactive. So we want to dim our lights. We want to add another feature to our scene to turn our lights on and off. And let's see if we go to Unity and actually see how maybe some of the scripting works when we want to actually change maybe the material and save the change in the material actually also in a CSV file. We could theoretically then import actually in Dynamo afterwards. Good. So we have here a little bit of a table from the last webcast about all our applications here, and the applications here, of course, they have different advantages, disadvantages. You probably wonder why actually I put actually Navisworks in. So it's actually for the designers actually also a bit of a game developing application. So it's not only just for clash detection, you can actually do a lot of more actually with Navisworks. So even when you walk through, the door automatically opens and actually other interactions. So it's very easy and simple to actually add interactions to Navisworks, easier than actually like in any other application. And the downside of Navisworks is that unfortunately I don't have seen any plugin or so where we can actually plug a headset in. So Navisworks offers to go actually to do 3D TV. What we can do with Navisworks, so you need to have your shutter glasses or IO goggles and look at the TV, so it's possible, but we can't do true VR, so with a headset. So a head-mounted display is unfortunately not possible. For this, again, yeah, we have Enscape, this or Revit Live, and they actually allow us all the way along. All of them, they actually allow us to experience here head-mounted, experience the scenes through head-mounted display sets. Good. The cool workflow is when we actually use Revit Live, we can actually take this project to interactive. This is one of the first projects we actually want to actually demonstrate how this actually works. And yeah, looking into walkthroughs, we can actually easily set this up. Going into any object interaction, yes, even Live can do this actually with interactive. Any material interaction, yes, we can do this, for instance, also with interactive or Unity. This is what we want to what I would like to present. If you want to spit out any animations, so to do some production, a bit of an editing, it's actually also possible. There's some cool examples actually with Unity actually around. Good. So if you want to connect with any additional others or any other control, obviously, yes, they actually should all support this, because this is what we actually want to look into. Coming up with Internet of Things and actually getting our city actually smart. So talking about smart city, that buildings are actually connected with each other, and so basically that they optimize actually themselves in terms of lighting, in terms of any glazing or anything else with it, then, or be it, for instance, even access, we can actually also develop here applications with interactive and actually Unity. There are some cool examples with Unity around and about, which would offer you to have here or make use of the digital twin basically, and connect this actually with the physical model. For that, good. So we talked a little bit deeper in the last webcast about these, and just a little bit as a recap, what these applications actually can do. Good. It's always when we want to try to implement a new application, how easy it is actually to learn a new application. And so I have here a little bit of a diagram, the time you probably might need to implement one of these applications. And so hence having a very flexible environment, for instance here with Revit Live and Interactive or with Unity, to do a more complex, to design more complex solution for our virtual reality is probably it's probably good. It's probably very, very easy. It's probably a good time frame. So it unfortunately, because we do with Unity programming, or we require actually some real line code, unfortunately it takes a little bit longer. But the results are definitely stunning, what you can actually achieve and what you can actually do with it. Good. So yeah, quickly catch up about our A360, where we actually find this. We just go here into render in the cloud, and our dialog will pop up, which then allows us here to select a stereo rendering, and we can then experience this. We have then with these codes, we can send the QR code to our client, or a big long code in form of like we have it for maybe in our web browser. By the way, we can actually experience this in our web browser actually as well, and basically watch the rendering and have this interactive landscape. Just as a tiny recap, you might have heard about this in the last webcast, where we then also can here interactive walk with it and walk through, where we have also a virtual reality headset and can experience this. So attaching a virtual reality headset is basically nothing else than just attaching actually another monitor, or two more monitors to the computer. The only tricky part is that the hard, so basically the graphic card, needs to be a little bit more powerful, because the software needs to address these two screens for your left and for your right eye actually independently. So not like commonly Windows which do this. So in general, the graphic card needs to have at least twice the power, or better, 3 times the power, to generate actually these frames with at least 90 frames per second, because otherwise you might feel actually motion sick. We have here our Revit. When we go with Revit, for instance, here actually, if you want to go live here, and this would allow us to convert actually the scene. The part is, or why we actually have to do this, is that we actually have two types of system in our computer world. Good. So once it's being converted, we have this then with our interactive, with our live user. With our live application, we can actually explore this. In the meantime, we actually have also whole projects. We can just double click on it. They actually run on themselves, so that we don't actually need any live viewer anymore. You only need a live viewer if you want to do a little bit of an authoring about different scenes, or adjust a little bit your presentation. But today we actually want to do this with with interactive and have a bit of a play. Good. So I thought the two guys here I want to show as well, because they actually represent in general how you can achieve represent a philosophy how we can achieve a better efficiency and productivity. And I like this actually because when I'm sitting, for instance, in the morning or after work, for instance, and using public transport, sitting in the train, so everybody's looking at the phone, but who's actually making money with it and who's actually using it. So when you're just gaming or reading news or using Twitter or Facebook, but yeah, use your phone and actually program it. So that's actually also a good statement. So that we should become actually more and more aware of programming, and we should teach it actually our kids. and totally support this actually as well. Good. So now let's have a quick chat about the two different types of system and why we actually have to convert to this actually with live. So on the one hand side, we actually have our Revit running, and on the other hand, we have actually our live with it. So because we work in Revit and we want to have a very good, glossy, perfect presentation, we actually work with physical true materials. So we have here on physical true lights. So with Revit, we actually have a physical system, so kind of physical. I just thought I'd demonstrate this like it would be a little bit piece of whiteboard, so that you can actually follow this. So we have here with Revit a physical system, and we with this we actually use physical materials, and we have actually also physical lights with this. And we use here, for instance, with our lights, for instance, our IES files. So if you're an architect, you might have heard about IES files, which is basically what defines actually the shape or the fall off of your light in the environment. The physical system calculates or needs to calculate actually the image or the pixel we see on our screen actually every time live, and that takes actually a long time. So for this, we actually have with live a shaded environment where our materials and lights, where they actually need to be converted. So we can convert this actually manual with 3ds Max, possible, but we can make use of the live service, which does actually everything for us, which is much easier because I can set up my template in Revit, and with my materials, with my lights, I can just work as I did in the past. I don't need to worry about anything, and then I send it off to a server which does the full conversion for me, so I don't need to run actually here two systems. So the shaded environment actually means that I wouldn't call it simplified, but kind of that it's kind of pre-rendered. So we could say it's a little bit of a pre-rendered, or you find it actually also that is so-called it's actually baked together with your light, with all our lights and actually others. Whenever we look into a presentation and we want to look into a virtual reality presentation, and you have been on one of our 3ds Max courses, you probably remember that we have actually 4 assets we actually would need to look into. We actually would need to balance basically our geometry. We need to balance actually with our camera. When we do virtual reality, we have a fully artistic environment. So hence, especially when we want to walk through, or when we want to be actually interactive, and maybe show this later on in the Unity example, we need to find a solution about our horizons. We need to find a solution about where the building actually stops and ends, and what is actually happening at the boundary. So so world just doesn't stop there. So to have here realistic environment. And additionally, actually, we need to balance actually our materials and actually our lights with it. Here, just as an example, especially when the units are, for instance, wrong, it can happen that also your light values are, for instance, wrong. So that you have maybe the wrong lux value, that all of a sudden you deal with 100,000 lux, and unfortunately the intensity of light is not linear, so hence it might wash out your materials, and you might find, or you have a very hard or harsh shadow, which doesn't look real for that. Good. So they're actually all tied together, you could say, like a washing spider, and where we clip our scenes on it, and they're also tied together actually, that we have, wherever we go, whatever we actually set up, that we have the right units actually, and this actually we need to double check. So when we now have a quick look into our Revit, so come on, be nice to me. Keep them okay. We should find here, for instance, an example file. I'm just demonstrating this with example files here, and you might remember the example file. You can do this as well. So if you want to follow this, I can ensure that everybody actually has these files, and we actually see here our Revit example file. So what we actually want to do is we want to present this actually now in a virtual environment. So what we can do is now we can go to our view, and we just here go live and actually send this out. So what live actually then does is it actually offers us, or it actually downloads immediately actually a folder, and this folder, what we actually have here is actually the conversion which comes actually from the server. So we have our live project. This is the file you actually would open up with your Revit Live, but we have shown this in the other webcast. So we actually want to see how we can make this actually interactive. So our Revit architecture base example file here with a long number is actually our 3ds Max interactive project. So including actually also thumbnail and anything else and anything with it. So we can immediately actually connect and patch this actually to our 3ds Max interactive and start, for instance, exploring this. So in the first webcast, I had even a tiny run through some of these folders, what they actually do. So the advantage is when you convert it, that you actually also don't need to set up any scripts around and about your virtual reality gear, because it immediately actually includes this. So if you have, for instance, any units around and about, for instance, for your teleport, for also for your controller, as well as anything associated with it, that you actually see this in the scene, it immediately comes actually with this conversion. So it's really cool. Good. So when we go to our interactive, somewhere we should find a tiny interactive. Here it actually comes up, and gives me then here the opportunity to start a new project. If you have time, and yeah, well, it's winter anyway currently, and if it's a little bit rainy outside, just have a quick look into some of these online projects. There's some really cool fun stuff actually you can explore, be it, for instance, a subway, or which has a nice good graphic representation, or also the virtual reality museum actually, where you have a lot of toys you can actually play with. So these are commonly good scenes to warm up with this whole interactive environment. Good. So we have here some projects, and I want to add my existing project, which is my live project I just converted. So this is the folder here, which comes from my server. So live and then we have here just .stingray project. In the past, you actually had to unpack the Stingray project, and which was a zip folder, and then you could edit it as well. But here it comes already unzipped, and that's actually pretty cool. So I quickly open this up. We see actually our icon, and the icon I just opened up, and on the bottom we have here actually levels, because every computer game has, so to say, levels. So this is how this is being organized. So when you have, for instance, multiple design options, well, so to say, design multiple levels for your client or for yourself. Good. So we actually want to take this project and then just open this up, and my interactive environment should now compile it, because we are actually in a development environment. It compiles. It compiles means that it takes my whole content, everything what I have set up, my materials, my lights, my scripts, and literally anything and everything, and gets it ready for the language and translates it, that the CPU can actually process this. So we see on the right bottom here, for instance, my data compiling here, and actually runs here through the assets. On the right hand side, we will find here our Scene Explorer. We find also our property editor. And now it might take a little bit of a second to compile the whole scene, but then it should actually work. It should be actually nice. Should be actually nice to us. Good. Gives you a little bit of a second maybe to talk a little bit more about the user interface, so we can actually adjust this, which is good. And on the left bottom, we have a little bit an Explorer-like environment where we can actually browse the assets. Because we develop, we are working actually with a project folder. We don't work with an own file, so we have a lot of individual files. They're connected with each other. And scripts, they have been programmed and associated with our geometry or with our environment. On the top, we find, for instance, here then our viewport. It's currently gray because it's currently still processing actually my file, and we are done. Now we are pushing through. Very good. And then we should actually see immediately our example file for that. Good. So we can actually also create something in our environment, but I believe it will not be your first application where you start modeling something. Especially, our gaming environment is actually using a mesh geometry. It's not using parametric solids like you would have it in Revit. Is it possible to change maybe some of the geometry or move the geometry around? Yes, certainly, of course. So you find a lot of scripts in the web which would, for instance, allow this to do so. Good. When we have a look into Unity, for instance, here's another example. Unity, you see, it has a very similar layout for that. Also, Unity actually allows and has on the bottom actually an Explorer, and on the left-hand side, actually, my assets. This is what we have not in interactive, but we have, for instance, also here the option to browse and see actually the scene we are actually working on. For instance, well, as soon as you, for instance, select your asset, you see actually the properties in your inspector on the right-hand side. When it comes, for instance, to any lights, there's actually also a fishing trip and a fishing ship where you can go on a fishing trip. See around, yep, and some of the other models. So any interaction is then, or any script is then being added on to the to our component. So let's see if Max is nice to us. Yes, interactive 3 is Max interactive is working nice. Good. So we probably need to zoom out a little bit for that, and no, come on, be nice. And so quickly about the navigation here. How the navigation actually works is obviously we use the left mouse click or the left mouse button to select something, and we use the middle mouse button. For instance, we can pan, and the right mouse click. So the right mouse button, where we can actually roll our head. So just be a bit sensitive. It's a bit sensitive here. If you do your left mouse button and use your Alt, you can actually orbit from your point where you're currently at. And if you use your middle, so your right mouse button, sorry, with Alt, you can actually zoom in and actually zoom out. So brilliant. And need to move this up a little bit. Good. I actually also always wondered about the red roof, because I think the red roof here is actually very, very poppy. So if you, for instance, want to touch up the materials here in interactive, you can actually do this. It makes use of some of the basic maps, be it, for instance, a diffuse map, or be it, for instance, a texture, and actually also a UV map, for instance. When you want to develop, or when you actually want to add on any assets, they need to be within this project folder. Same thing is like in Unity actually as well. Need to be within this project folder. Then you can actually connect and patch it up, and the project actually knows and understands that you can actually have here your artificial world and apply then the new texture to your new artificial world. So let's select, for instance, this roof. We get also our common gizmo when we want to move these around and about. On the right hand side, I need to touch up a little bit my Explorer because otherwise I don't see actually my materials down there. So I need to just drag this up a little bit. And there are my associated materials. These are actually the materials converted coming from Revit. And you see here these two materials which show actually that we have here kind of, I think, 2 layers or something. We have here the gypsum wallboard, which is probably the inside of our roof. And then we have actually also here the metal something as which is basically the red part actually of it. What I really like is when you actually work here and touch up your assets, you can actually immediately, say for instance, go to the resource. And when you click on this, then the machine works and looks and searches the resources for you. When you have an artificial world, you of course might have dozens of resources, which might make it actually a little bit harder to follow. So hence, it's good to have a very organized structure. So if you want to store all these files just on your desktop, believe me, you won't be happy. Good. So hence what we actually want to do is, let's change this red material a little bit. I think it's a little bit poppy. So I would go here maybe to my data and use a right mouse click and say, for instance, I want to create a folder here. Let's call the folder, for instance, images, something where we want to add on my custom images. So my images I want to add on. Have a folder created here, which actually also did create a folder actually on my hard drive actually as well. So let's go there. And I can be nice and open up. And we want to import some assets. So with the assets, we see that it literally understands anything and everything about what we need to develop an artificial world, even actually our IS files. It actually understands and can also work with physical lights. Which is cool. Somewhere it sneaks and fakes something around the physical around the physical parts. So it does it very good. Looks quite cool. I like physical light. So we have our scene files, for instance, FBX files we commonly would bring in. So because we are in the presentation, we are in the render environment, we use our Filmbox format as like we can actually also export it out of Revit actually as well. Good. Somewhere on the desktop folder, I've prepared some material training folder, and there are a couple of materials actually around and about we can make use of. Let's say, for instance, and you see that we have always a texture. And we have also a UV map with it. So the UV map basically adds on some geometric information to the surface. We can actually not model because it would be too intense. It would there would be too many polygons. It would so hence the computer wouldn't be able to actually to process these. So we have, for instance, here some tiles on it. Well, not. Let's make use of these tiles here. And I have, for instance, here the textures, and just open this up, and then they should actually now appear here in my folder. So 191, good to remember. So I have here my normal map, and I can just click on it, and okay, I have maybe here some other. Didn't look like tiles, but we can make use of the normal map. So let's select it. Let's make use here of our material. Let's go to the source, which is the red one, and we see actually here my bump image. And when I go over here and select maybe source of our dialog will come up, and now I can actually search, for instance, here for my image. I have adjusted it add on. Let's add on here a little bit of a normal map, and we see now here we have our material on the right hand side of the right bottom. When you actually have a look in the scene, it actually also updates it. That was here we need to go. Just slipped from my alt bottom, hence I started just rolling from my rolling off my head here. Can happen. And so and then we see a little bit of a texture actually on it. Why not? So we want to have the bump map a little bit more crispy. Let's say we want to have maybe a 5 here, in my bumper amount and my value, and we see there are updates. So now we get actually a bit of a texture on it. It's good. So the tint color sure is red. Now, come on, we want to make this maybe also a little bit more greenish here, so that it kind of blends a little bit more into the. That it blends a little bit more into my. But however, I'm actually working with my tint color here. We actually need to have my generic color up there. We actually need to work with. So I believe. So let's see. Otherwise, we can try both. So make this maybe a little bit greenish here and see. Good, didn't change too much. Here we are now together. Together we are strong. So I have my tint color here. Make this maybe a little bit darker. That it blends a little bit more into the environment. That it blends a bit better into the environment. It's good. So now, when you say, for instance, you want to change maybe just simple the color, select it, for instance, here. We find also, for instance, here, it's a little bit more. We can maybe adjust here. I think for instead of having maybe this brown wood, we want to have maybe here, maybe a little bit of a bluish wood, for instance. I think it's here somewhere our finish interior timber cladding. Let's go there. Let's have a look into this. And does it change it? Yes, makes it, for instance, also a little bit bluish here. That's good. Hit OK. And we want to add maybe also a little bit of a different bump map, for instance, here. Let's choose, we had, for instance, here, the 191, for instance, add this on actually as well. So we see that we can still actually adjust this afterwards. And also we can work here with our sizes, tile it, make this a little bit different here. And we see that we have actually a nicer different cladding. So anything you can set up, you can actually also adjust. So good. Good. Let's have a look a little bit into the lights, because we want to make this here actually a little bit interactive. That's what the whole session is actually about, how we can actually do this. And so let's say, for instance, we want to have here I probably wouldn't get a job as an architect. Good that I'm an engineer. And we have, for instance, here our lights. For instance, here, maybe we need to zoom in a little bit more. We can basically zoom into the building. Then we can select, for instance, here our lights. Good. So we have here, for instance, our lights now selected. And so I want to add a little bit of a functionality to these lights to, like it would be, for instance, a game that I can, for instance, want to dim these. We have here now the option with our level flow to wire up logic. Similar, you're probably familiar with Dynamo. We can look, for instance, here for our lights on the right top and say, for instance, here light. Take, for instance, the unit, literally basically in here, and then start wiring up, for instance, here our logic. We, like in Dynamo, we wouldn't have the option to look for our nodes. We can access the nodes just through our right mouse click. So we have here our level unit we actually want to work with. Let's make use maybe here of the right mouse click and say, for instance, we want to work with our lights. And when I want to change my light intensity, I first actually need to get it. So get here light intensity. And then when we can get something, we can actually also set it. So lights, here we are, not to the level, to the light we need to go down. So set light type, light intensity. Good. So that's all right. And now we can shuffle this around a little bit to keep it a little bit more logical. So take the unit, and wire up, for instance, the unit. So which produces here a blue value. Blue actually means here that it is like a number, it's like a value, it's like 1, 2, 3, 4, 5, or actually also with a decimal. This we need to change, obviously, because when we have the same light intensity we get, and then we set the same, it doesn't make any sense. So we need to tell the computer that we want to process actually this value. Using a right mouse click, we can actually work here with some number data, where we can actually set a specific value. And let's say I would have this value set to 1. And then we need to actually join these together. So it's like as programming, and we need to find a solution here under M, where we find here math, numeric, and we find an addition, for instance. So like a little bit of a interactive. So anything which is interactive is commonly programmed. So good. So we have here our count intensity. We add on a 1, and then feed the value actually back into the intensity when we want to change it. So when should this happen? So we have here on the set light intensity a tiny in here. So when I press, for instance, a certain key, I have all kinds of inputs I can work with. So also when you go, for instance, to your Oculus, for instance, input, we have thumbstick. Somewhere we actually have also our SteamVR. For our HTC Vive. Also when you run, for instance, your Lenovo or your HP or Dell or others headsets, they actually also run on SteamVR, the widest platform. Here, make use of your inputs. Actually, here is one, for instance, button touch. I'm just demonstrating this here now with the keyboard. Somewhere we find here input, I believe, and keyboard button, for instance. We have actually also here PlayStation, Xbox inputs available. So when you present your architectural design, or when you present your building, the artificial world you did create, if you want to offer this to a client on a PlayStation, for instance, to explore, then you can do this and compile this actually as well. So when my button is pressed, please do so. What button should be pressed? Let's say maybe we want to have maybe just my Z button, just for the sake, to test this out, because it can be changed. So then this should happen, and this should work now. Good, we can zoom in, zoom out here. I get my light 1, so we can now watch out for my light 1, if we can actually dim this then afterwards. But dimming actually means that we also would like to change it in other values. So I can just copy and just paste it, for instance, and say, for instance, here in my logic, I would like to maybe actually also change it. And I have my unit connected, and I have my other unit connected. However, the value should become less when we have here become less when I press my X button. So I think X should actually increase. So this should be Z. And if I want to change something, and then we have here my X. Okay, great, fantastic. So X and Z, like on the left bottom of the keyboard, then the intensity actually should change. So running through, just double check, Z is -1, and then we have +1. Should set the light intensity for the unit. Good. So once we are done, we can actually go back to our flow, and it's important before you actually compile this that we actually save everything. So go here to a tiny save all. And upside, do you really want to save the materials and so on? Yes, it's good. Let's save this, and then let's run this. So what you actually see is then it's being compiled, and it looks like it is like what we have in live. Here we can go to our tap and go, for instance. These are the scripts which are here available. When we can browse, we see actually here the change of our materials, a little bit the greenish roof we actually have. We also have here the our bluish pattern. So let's go a little bit to the inside. Let's get inside the building. We can browse around. So how do we test now the lights? Remember, we actually did a check of this light here. So for this, we actually still have access that we can actually work here with our sun. So I'll make it a little bit dark. And so I'll check a little bit our sun. So let's go a little bit here around, that we maybe see our light actually a little bit better sometimes. So there should be actually my light. And now when I go my reference Z, we see actually that we have here, just pointing to this now here. So watch out this area here, that actually the light becomes a little bit less. So now it becomes actually also more pretty bright here, or we can actually also dim it. So we can actually make this easy. We can actually make this interactive here, our scene. And so if you have this now with your VR goggles, if you experience this now with head-mounted display sets or with your VR goggles, and had that maybe with the controller, you can actually experiment, so to say, with your lights in this model, and discuss, for instance, the light settings, the intensity of the light, how does it actually look like if in the evening, how do the scenarios look like, or yeah, how does the design look like having, for instance, multiple scenarios. So for instance here, easily, the advantage is here, of course, we can just do a simple wire up of this. Can I still use some programming? Yes, we can still do some Lua programming. So for example, so if somebody's interested into doing some hardwire coding, we can actually do this here. And let's have a quick look into our script, and maybe here also as well, where we get some values. So we can still do this here, wire everything, program everything. What it actually also offers you to develop actually your own nodes here, if you know a little bit about the C++. I think it's some C++ programming. Good. So what other options do we have? Well, if you go to Unity, unfortunately we can't convert it. So basically you start developing and compiling your whole design from scratch. It's like you bring everything in from scratch, like into 3ds Max. Many actually do. And while actually also 3ds Max Interactive actually would allow our to work live with 3ds Max. So what you do in 3ds Max does actually also come through into 3ds Max Interactive. On the other hand, when you want to do some real programming, you're going to do some more deeper interactions, for instance, with sensors and others, or you have maybe a Raspberry Pi, if you want to connect this to your model to measure, for instance, any real-life scenarios, and want to reflect this on your digital twin, it's probably easier to do this actually with Unity. Good. So we have here, for instance, options where we can select these. And especially when you want to go, for instance, in Unity or so, we have, for instance, also our elements available here. These are coming in from our FBX mesh, including actually also the Revit ID. So including actually anything and everything we actually have here. So when you want to develop, for instance, here then a new script, and you want to, for instance, program this, also here, ideally, we have everything in our folder. If we have maybe a folder actually also, for instance, where we talk about materials. I have prepared here already a couple of materials, I believe. Yes, a couple of materials already prepared here to work with. And these are the materials I've just seen before. And good. So when we create now a script, we start here, for instance, with the right mouse click, here, start a script and say, I want to create actually a new C# script. How do we want to call it? It's a new behavior script. Fantastic. How do we want to call it? Let's call it, for instance, change material. Okay, so change material. Now we want to edit it. Let's open this up. Change material, Visual Studio, for instance. You can connect this with Visual Studio, for example, and have here, for instance, new behavior script. So for this, you need to know the code, because otherwise it doesn't work. And this code is, for instance, change. We have here a little bit of change material script, we want to call it. Good. So everything we do now is actually here in brackets. Everybody has a little bit its own way how you organize the brackets. You probably will find that I'm a little bit conservative here with my how I organize my brackets. We have here libraries running in the back end we make use of. So hence we actually also need to refer to some other libraries, because especially when we want to save the change, then we would like to, we need to access actually here our system. So hence we actually want to also use our system library, system.io, I think it is. You see how it actually comes up, and then we have a semicolon in the file in the back end. We may want to also include a using system and actually also a text just. I'm going to work this. We have a user interface from our Unity engine. Yes, we actually need to add this on as well. And our collections, which means that we actually also need to patch on Unity and an engine. And we have a UI actually in the end add this on actually as well, then it actually should work. Good. So we have here different methods. So this update method is actually the computer runs through the update method every frame. The start method, whatever, when you say, for instance, void start brackets, you would do this where the computer processes this method when the whole environment actually starts. Good. So when we update it, we say, for instance, when we have a certain input, for instance, if my input from my get key basically should be, for instance, 1. We're using here, so to say, a string. Then we would like, for instance, we need to work with a new material. So then something should basically happen here. And we can put this in the brackets as well. So we have, for instance, here new material, and we make use of our resources, our resource folder that we load the material in. And which material do we want to load in? Well, we need to give it a name, or we have set up the material already. What is it? It's a type of my material. And we want to have this actually as material. Can't change it, otherwise the computer can't process this. So we have some typos here. We have resources, and so resources, we load this in, and then we have here type of my material, type E of material. Do we have anything else as well? No, then it actually understands it. So then we have a new material. However, we actually need to instantiate it, so which means the computer needs to know that we're actually working here with this new material. Good. So we have here a new, so we actually need to define this first, material and new material, because otherwise it doesn't work. Neither. Good. So set this up as a new material, and we might find here, hopefully, no issues, or we find that we might have some issues. Good. This goes then basically down when we make use of some code, and we actually write this then basically actually out and supply actually this code then to our project. So before we actually here have a big play, because it would be probably pretty boring on our webcast. Now here, that we actually type this in, because you can spend a lot of days and nights actually hacking your script here. Do you want to keep the changes, save the changes? Nope, actually not interested, because in our Unity, when we take this, I have here something. Do you want to delete this? Yes, I have here something, and I have a tiny XYZ script where I actually programmed everything already. So I just need to quickly rename it, that the computer actually applies this, and I have here, for instance, my change material actually, and then it should be actually be nice. So when you want to, for instance, double click here, open this quickly up, just reload everything, we actually see that I have here put actually everything in already for us. So what is happening here on the bottom, that I actually also have developed here a tiny method on how actually it actually records it. So any change, whatever we do, actually is being recorded, and then it's being actually written out into a file. When we now want to test this, we can go to our Unity as well here in terms of my interaction, and just we need to actually take my camera and, for instance, take the script and add the change material. The script we have here, we need to add this on, for instance, to our camera, to any other object. Let's do so. Add this on, and then so it's working with my main camera, for instance, here should work, and then we have here script change material. Let's see if it works. And if you want to test it here, there's actually also a node-based editor for Unity. Unfortunately, it costs a couple of dollars, I believe. I don't know how good it is, because in general, you're probably more programming. When you have these scripts here working, it's actually easy to apply them, and because you will find always to have the same type, the same way of interaction, or the same options you actually want to apply, for instance, over and over again. So let's run this here. It compiles everything, so it gets it ready for the CPU to run. And we see, for instance, here now that we can actually navigate interactive through it. When you would have now the VR goggles on, would actually work with the VR goggles actually as well. So you just basically tell your computer that you actually want to experience this now in VR. Stay tuned for the next 2-3 minutes. I will quickly show you how this works. So when I now point, for instance, here to a wall, then we find here that main camera change material has not been assigned. Good. Oh, we need to apply here somehow a camera to it, because otherwise it wouldn't work. So this is when we do basically some troubleshooting and debugging now. And I need to assign here my main camera probably to this thing. So main camera, change material, then it actually recognizes it, because otherwise the computer can't process this, I believe. So should be nice now. Oh, fantastic! Something does change. Oh, I have chosen here in our example some poppy colors here to that we actually see the change. And when we now have here these interaction with the materials is then actually also being saved, basically being stored in a CSV file. We can actually also then open up or bring in back into Revit. So we're somewhere here, we have Revit Advanced, and there's my CSV file, for instance, here, for example. Quickly open this up, and you see I was playing just before already with it a little bit, and which changes, for instance, it records actually my interaction actually with it. So how do I get these? How do I get these the project actually ready for my client? And this is, for instance, when we go then here to my build settings, that we need to build this, that we basically compile it, have a final compile process for my here in my project for my clients, and we can get this ready, be it iOS, be it for Android, good for TV, and have your player settings, for instance, up and running, where you then can set up your settings, your icons, your run behavior, for instance, with and for this particular environment. So every environment needs to have their own libraries actually installed. For instance, also when you do Android, you need to install Android Studio, and they need to refer and cross-reference these actually back, so that when this application compiles and bakes and seals off this project, that it actually also runs, for instance. So going, for instance, also here, for instance, for Windows environment, for example. So you have, for instance, here our player settings. We then actually have here the option to work also with different splash screens. For instance, here if the logo actually should show, you can actually also design your own icons. For instance, I've here just took a screenshot for this, and then, for instance, here how the presentation should actually run in full screen or not. On the bottom here, we have actually quickly our virtual reality settings. For instance, here. So I can't change this now because I'm still in my player mode here. So when I would go out of this player mode and go back here, then we have, for instance, here our virtual reality supported. If you, for instance, want to support it, what type of gear we actually want to support. You might want to work with OpenVR, for instance, with a Steam VR set, and then we can just add this on and select this. So it's not much we actually need to do. It's like you would plug two more screens in, one for the left, one for the right eye. Only thing is that, of course, we would need to need to have a bit of a stronger graphic card, and then we explore and experience the virtual reality. When you want to do this with interactive, going back, we actually also have here the option to compile this actually as well. And so it's called here the deployer. So add a tab under D, we should find here the deployer, which would allow you here then to adjust the settings in terms of your Android, iOS, PlayStation, or also for the web, for instance. And then you basically just say package your project for Windows, and you have your Excel file where you then can explore, and the client can basically touch up and have a play with the lights, and basically you can send you then the recording of any change, for instance, if you like to. So good. So I hope you had a little bit of a fun exploring here and seeing how everything works, keeping actually our how we can actually have our virtual reality landscape where we can add some interactive technology to it. And yeah, so in the end, thank you very much for watching, especially all the 3 webcasts. Come on, show me the other webcasts here. This picture I want to have here. Big thank you. And so hope you stay tuned. And if you have any questions, just get back. Don't be shy. Send us an email. And if you want to know more, and so I hope you see that it's actually not too complicated with the virtual reality. There's some good applications out there. It's easy to include the client in the decision making, and also programming is actually not too complicated. Remember that we can actually pre-manufacture our scripts, and you run. And yeah, if you want to know a little bit more and want to get maybe also on our training course, just let us know. And with this, I leave you and have still a wonderful, great day.